In this video, I want to go over with you what we've done in Module 1 and what your first exam will cover. So Module 1 covers basically the first three chapters in the text. It covers the definition of statistics, which is just an umbrella that catches everything, right? The collecting data, summarizing, organizing, analyzing, interpreting numerical and categorical information. It's kind of what we do, anything data related, data driven. The world we live in now, we see a lot of data as it revolves around this virus. What we want to try to do in statistics is make some sense out of it. We began with a general discussion of two types of statistics, or two branches or areas: descriptive, where we're describing the data that we have in hand, and then inferential statistics, where we take the data that we have in our hand and project it onto a bigger group of data. Now, the data we have on our hand, the bigger group of data, we've kind of gone on and formalized them and talked about population experimental unit. Everything in the data set that we're interested in is referred to as the population. The sample is the group of that population that we've collected data on, hopefully randomly. And then the experimental unit would be a single one. So if we're working with USF students, all USF students would be the population. If we talk to 100, that would be the sample on the 100 USF students, and then a single USF student would be the experimental unit. We collect variables from those experimental units. So I ask a USF student how tall they are, what's their GPA, what's their gender, are they a full-time student or not. Some of those are quantitative, some of those are qualitative. Quantitative are numerical, qualitative are the categories or categorical data. Measure reliability. Our inferences allow us to take sample data and make statements about populations. Now, we haven't done that yet. I introduced the concept or the idea of that, but we'll actually see those inferences later on when we do confidence intervals and test the hypothesis. So reliability will play a bigger role later, but the inferential statistics allows for that. I mentioned the quantitative and the qualitative data. We talked about three methods of collecting data, or where does data come from. There's the published source, there's the designed experiment, and there's observational data. You should know the differences between them. If I describe a situation to you, you're going to need to identify which type of method was used. I have to do a good job of describing how the data was collected. Random sampling, that came into play on your first project, right? I had you talk a little bit about a random sample, but a random sample is a technique where every single unit in the population has an equal chance of being selected. And we talked about a couple different techniques for doing that. Then we move to our descriptive statistics. So chapter 1 kind of introduces some general concepts. Chapter 2 talks about describing data, and we can describe data graphically and or numerically. And if we're going to do graphical displays, I've listed some that we're going to work with: pie charts, histograms, box plots, stem and leaf displays. There's a scatter plot that I didn't look at that you'll see more in a Stat 2 environment. So any kind of graph that pictures the data, the pie charts, and one form of the bar graph is used for qualitative data. There's another bar graph, sometimes referred to as a histogram. Box plots, stem and leaf displays work with quantitative data. So you should be able to interpret. I'm not expecting you to draw any of those particular graphs, but when I present them to you, you should be able to answer some pretty basic questions. I talked about three measures of spread as we move to the numerical side of the coin: the mean, the median, and the mode. You should know what each does and be able to interpret each of those for me. The mean and the median are the two most important. Mode's kind of a throw-in that we don't use all that much. When it comes to measures of variation or dispersion or spread, standard deviation is the one I'm going to want you to be knowledgeable about. The standard deviation helps us to determine where most of our data set will fall. And for most data sets, whether they're skewed or symmetric, we use the empirical rule or the modified empirical rule, and that tells us that most of our standard deviations, most of our observations fall within 2 standard deviations of the mean, I should say it that way. And then if you are forced to use something with Chebyshev, then we say most of our data falls within 3 standard deviations. And we saw in chapter 2 a theme: the shape of the distribution dictates whether we're going to be looking at 2 or 3 standard deviations. It comes into play with our standard deviation interpretation. It comes into play when we're trying to detect outliers using z-scores. Speaking of z-scores, that's one of our measures of relative standing. We have z-scores and we have percentiles. Percentiles always tell us a percentage of the data that fall below a particular point. So the 75th percentile has 75% below and 25% above. The 30th percentile has 30% below and 70% above. Those are the only two measures of relative standing. But we have three rules, and let me get rid of this. We have three rules that you guys are used to working with or should be used to working with. Chebyshev and the Empirical are the two that you see everywhere. Any Stat 1 class you go to will give you those. I added in the modified empirical rule because I'm expecting you guys to work with some skewed data in your projects this semester. And really the way I want you to think about it is these two kind of give us similar information. Most data falls within 2 standard deviations of the mean. But you should know those rules. Chebyshev's relative theorem, the empirical rule, the modified empirical rule. And then we talked about outliers and methods of detecting outliers. We saw 2 different ways of doing it. There's the z-score method and there's the box plot method. I think you got a little bit of practice with both of those in your project, but you should be able to identify the outliers in your data set using one or both of those techniques. And then the probability I made pretty easy for you, because the only thing I really had you worry about too much with probability is the probability table. I talked a little bit about some things, but for the most part, when I present a table, you should be able to answer the AND questions, the OR questions, the conditional probability questions, and if you have questions with those, you can go back and review that particular video where I talk about probability. But it's pretty straightforward stuff. Take your time when you're doing any of this stuff. The first part, the first module, is the easiest material of the semester. So you want to take your time when you're doing your assessments. You want to take your time on your project. You want to take your time on the exam. Get as many points as you can, because the class will get more difficult. To help you prepare for the exam, I've put together a sample exam, and I've called it something clever like Module 1 Sample Exam. Now, as I'm filming this, it's before the semester, and I haven't put together a video. I may do that in the future, or it may already be here depending on what semester you're looking at this, because I may recycle this video because it's pretty much the same from one semester to the next. But I intend to come up with some answers and show you how to go through that sample exam and come up with the right answers. So I'll be posting them later. But that's a pretty good review of the topics that we're covering. I'm gonna create an exam and ask you about these particular topics. So get to work. Get working on competency checks and assessments and projects and see what you can come up with. When you have questions, discussion boards, online office hours, really good way of asking me or the TAs to help you with the material. So good luck, and I'll talk to you soon.